But let's go into the real fun section, which is around operators. And operators are really one of those things that particularly I find them a very fun part of Nextflow, in the sense that they're very powerful. They're kind of this way of really kind of running through and doing massive modifications on your channels. And the fun part about them is that you write a very small expression like collect, or if you want to join something together, and you run it through with your test pipeline, and it kind of runs through a couple of different elements, maybe a couple of files. And then the same thing works 100% directly, exactly the same for 10,000 files or hundreds of thousands of files. And this is the kind of powerful part of the data flow bit that allows you to do this. So let's have a look at some of the common operators. If we look at the documentation here, you'll see that there's something like 50 different operators. So I'm going to go into operators. I haven't counted them in a while, to be honest. They are split between a couple of different types. The types are not like really clearly defined, in the sense that it doesn't mean that it couldn't go in multiple places. So we're going up to option 7 here. There is the basic kind of filtering ones. We'll see transforming, which is just general transformation. Splitting, so taking a channel and splitting it to multiple channels. Combining, obviously taking multiple channels, putting them into one. And then there's kind of forking maths and some basic other ones like viewing. We have this example here of visualizing what's taking place when you're doing an operation on channel. It's actually a copy. You're actually creating a copy of the channel with every operation that you perform. And this is kind of goes back to the bit about not being able to duplicate them, because if you do an operation on it, then of course you've actually created a kind of version of it. You consume the original one and it no longer exists. So when you are in a situation here with this channel containing 4 elements, 1, 2, 3, and 4, we perform this operation map, which is just a general operation. And here you'll see that now we have the syntax for doing this. The way this works is you can read this as take the item, basically take every item in that channel, every element in that channel, and transform it into the item multiplied by itself, multiplied by that. And that is the new channel that we've created here. So we're creating a new channel from the nums channel, and we are taking a map, which is just an operation here, a generic operation that's going to take an item, multiply it by itself. So in our case, we have 1, 2, 3, and 4, and that becomes 1, 4, 9, and 16. This is a visual sort of representation of what's taking place. And this new channel has this name here, which we can see. So there are some basic operators that we've seen before. And the operators, they typically have a kind of like a default way of working, like by not providing any parameters. So like, for example, view here, the default way that view works is just to view, just to print to standard output each of those elements. And in this case, each element is on a new line, which is the way it's kind of works in this case. Then there's also an optional parameter, basically an optional way that you can say how view works. And here in this case, we use a curly brackets to define that. And I want to show you why that's the case. Let's just start with this and go into here. So I'm going to create a new file here, which I'm just going to call my, okay, I should continue on this one here. So let's save this and run this through. It's going to create now this channel, 3 elements, seen before this. What we're trying to show, though, in the example below this is this kind of alternative way that you can use view. And the way that this is built up is it's saying, well, you can provide an optional parameter. That optional parameter goes inside of these curly brackets. Now, you can start now to say, how do I reference the actual element itself? And the default way for referencing the element itself is this IT. So you'll often see in all of these things, you'll see IT. And it just means the element. So in this case, it's super, really not doing anything different. It's just printing the item itself. So it's going to go through here and print the item. It's really doing nothing else. We could add in something here. So we could say, actually print the item with a space before it. Run like this. And when you define this additional parameter, you actually don't longer need this. So this is exactly the same as before as well. So don't try not to get too confused on the syntax here. If you want to look up, it's called what's called a closure. You'll see it right directly under the section here that we're looking at. You'll see a description of those closures and how they work. For the most part, you can look at examples of how this works and see how they go there. So this is the basic one for view, which we've seen a few times before. We can also see map, which is a way to do a generic function, so any function with a closure. Here is an example where we're saying creating a channel with two strings, hello and world. And then we're going to map, basically create a new channel, taking the item and reversing it. And we can see that it sort of runs through in this case here. So let's take that, save that, and launch. I just created a new channel that's able to do that. Map is also quite useful in that it provides us with a way to manipulate the way that the channel is constructed. What I mean by that is, we remember when we had like the file, and we had like the file itself, we wanted the sample ID plus the file. So we kind of want to separate this out. And with something like map, you can define that, because you can say, okay, I want to know, I don't just want hello and world reversed here. I also want hello and world the original way. And then imagine I also wanted the number of the size of the string itself. So what we can do here is we can create this by saying, okay, I want the new channel to be a tuple, which we can do with a square bracket. I want it to contain the item, which in this case is just hello world, the item reversed. And then I also want it to contain the item and the size of the item. This is just a generic function that we're writing in here. And I close my square brackets. Now, the element is made up of a tuple. We started with a single element, and that tuple is made up of hello reversed and the number of elements there. So generic manipulation of your channels and your thing. So map becomes pretty useful for that. You often will see this item here can be written in another way. So you can here, we're just defining it like with item as this. But if you remove this, you could also say, for example, word, and then you would refer to this as word in each case here. So this is this one here. So I'm just referring this to word. So this is like an assignment. This is like overriding what item means, and then I can reference it. And then the other kind of point where this becomes important is that imagine that I have a tuple already. So my channel already consists of a tuple. How do I reference it here? Because here I've got like word itself, which is single, but how do I reference it in another one? Well, you can map these things on top of each other. So I can say, okay, we'll take the output of that operation and then do another map. In this case here, I've got like word. I've also got the next thing, which is made up of, which is like word reversed. And then I've also got word, and again, it's just the assignment on the fly, word size. And I could even cut it back down again. I could even say, okay, go back to just word for this. And now I've kind of, my channel's kind of gone up in terms of the size, and then I've kind of pulled those things back down together. So this manipulation is taking place in all the ways of doing it. Other kind of basic ones for this is, we saw before about into, and this was a way of defining like a duplication of a channel. So here I've got a single channel. What if I wanted to use this in multiple different places, or split it, basically, kind of split? So I would say here dot into, and here I can define two different names. So I could say like foo and bar. This is like the construction of two channels on the fly, foo and bar, that are just duplicates of the original channel here. And I can say food view. With that pretty trivial there. We saw at the very end of yesterday this ability to mix these things together. Catches you out there. That should be shouldn't be a comma there. When we look now though at our combinations though, we had our quant channel, and then we mixed that in with our FastQC channel. We can also do that and see this an example with, say, more simple values. If I have a channel 1, 2, 3, single channel, and then I have, let's just call this channel 1. And you'll also notice here that it doesn't matter, like it's splitting these things across the line. So it's not worried about the syntax if you want to mix that up. Channel 2. we've got A and B. Imagine if now we wanted to combine these things together, we can see something like channel 1.mix with channel 2, and then I want to say view that, the contents of that. And this is just a straight mix, so really just a like a concatenation of those individual processes. We can start to see interesting things when we want to change the shape of the channels. And what I mean by that is we saw collect, where we were basically taking all of the files and putting them into a single element. But we've also got flatten, which is the opposite of that. If I had two lists, so here, imagine that I had a list, list 1, 1, 2, 3, for example. And then I had another list, which I had 4, 5, and 6. And I wanted to then use those as inputs to a process. And I wanted to run that process for every element. Now, by default, if I was running like this here, and I said my channel is a channel from list 1 and list 2, list 1 and list 2 here. When I ran this itself, this would actually just be 2 lists. So the channel contains 2 elements in this case. And if we do a view on that, we should be able to see that. And we go here. But one of the things I wanted to take, imagine if those were samples here, and I actually wanted 1 to run, and I also want to run 2, and I want to run 3 independently in parallel. I can simply add in here, flatten. And now I'm taking that list of channels, sorry, I can take those elements and flattening them out completely to run that. And this sort of spreads the whole thing out. And now I would get 6 tasks running. I'm running for this. The complete opposite of that is collect. So if I had this now flat channel, and then I wanted to collect on it, I could run this here, and this is just going to bring it back together and run it all together as a single element. And run that, yeah. Let's do the last example. This goes back to the point around sample IDs and how we can manage those in different situations. So we may want to use a sample ID and kind of file structure as part of our channels, because we're going to do manipulations on them. We can often be in a situation where we have a sample ID, which is the kind of key thing that we are using as a key. And what I mean by that is, imagine our tuple, imagine 1 was a sample ID here. And the letters here were files, or the letters here were some other value here. If I view this by itself, just view through what exists here, this is going to create now, so I've got this channel, contains all of these elements, and they're kind of independent. What happens if I wanted to take, okay, actually, I want to group by the sample ID. So I want to pull all of my samples that match sample ID number 1 together. And I want to pull all the sample IDs that match number 2 together, and all the samples that match number 3 together. I can do that by using what's called group tuple. So group tuple here. And this is going to create now a list, or essentially going to create that channel, but it's going to manipulate it in a way where we're going to grouping on the sample ID. Basic example would be grouping on 1. So it's going to find 1 with A, 1 with B, and then 1 with C. They become a single element in the channel, 2 with C, 2 with A, etc. as it goes through. This is often used in like sample IDs. So if you will have like the name of your sample here that you want to kind of group that based on, you can do that. And there's an exercise there if you'd like to check it out. This is under 7.2.7 for doing that. There's the same thing about doing this. And here we're kind of grouping from a single channel. But if we have multiple channels, and this is probably something which is most often seen, you'll have like multiple channels. Maybe one process has gone through a particular kind of alignment. The other process is defining a particular type of analysis, and you need to bring those together based on a sample ID. And for that, we can do a join. And the join works similar. Imagine that we had these samples here. So it's just our alignment samples. So this is our alignment channel, which came from here. And then we had our, alternatively here, we had like our analysis one. So I have here this channel here that went through, and then imagine that we have these things with different files. This could even be like a.text or something similar, b.text. And now the point was we want to join these based on that key. So based on the fact that we have this common part, this one should be joined with one should be joined with one here, two should be joined with here, three should be, etc., all the way through. And if we do here, we take the alignment channel and we join it based on the analysis channel here, and then do a view. We see that we get this situation where we're creating a single channel, and that single channel contains the joining of those two things. Now, in this case, if we look at it, one goes with one here, one goes with B there, and two goes with C there, but we don't have anything else beyond it. You have a whole bunch of options on doing this. The way that we're running it here is the kind of default one, but you can join on a different key. In this case, we're joining on the first key. So we're always joining on the first element here. And if you go into the operators here, for doing this, you'll see that there's a way to define exactly which the key is. But I think we're getting towards the end of this section. It's a pretty intensive day in terms of syntax, in terms of going through everything. And I wanted to provide a little bit more of maybe a more meaningful example in terms of what this practically looks like in terms of your application here. So I just created a couple of examples for the next few operators to show what it would look like. And the idea here is, imagine that we had a process that was generating channel. And here you can see that I had the structure of those elements was made up of a tuple, which was the mouse, for example, the sample ID. And then I had some read here, and then I had human, and then I had cow, and then I had mouse again, and then I had human here. And you can see that this is reads one, reads two. The point of this is that we want to group the things, essentially group our elements based on a key. And that key in this case, by default, is the first element of that, so the sample ID. And this is how group tuple works in its default case. So when I run this command now, if I'm going to say Nextflow run here on group tuple, what we're going to see is it's going to group each element based on that first key. And this is a very common pattern that you will see where you may run things massively in parallel, and then you need to take them all together. And here you can see that it's group them based on mouse, and then we've got the two mouse trees, we've got human, and this would work whether it's two samples that you had or 2,000. So it really kind of scales up massively here. And often when you're writing this, trying to figure this out, writing little test cases like this or being able to very quickly prototype it in terms of an example can really help in terms of getting the structure right for what you're trying to do. Now, in this case, we are running with the default version of group tuple. This is just where the default is grouping based on that first element, but kind of showing you how much we've covered here. We've gone through the processes, the channels, and now we're up to the operators. And if we look at the group tuple one here, I'll just quickly, sometimes it's easier to find here on group tuple. When we see it, we can see that this is the default way of running it, but we can also add options in there. So we could, for example, not group it on the first key, but base it on the second. In this case, you could see, you'd say by one. And this is the way that you can basically just to decide how that works. There's a whole bunch of other parameters that you want to do here. So for example, on sort, you could sort them, basically sort those second elements. You could choose how many in terms of size. And then you've got remainder. In this case, we're basically going to say, okay, I need there to be two elements. So if we take our example and we say in here that we want to say size, I'm expecting there to be two, meaning that I need to have, in this case, two reads or two elements there to save this. We run this in the first case, and we can see that here when this prints it out, we can see that now, because we're expecting two, and cow, in this case, only had one read, it's not going to be passed to us. Again, to make another option on that, you could even say remainder here is true. And you can do it. And you'll kind of run through now, it's going to obviously add that. Now, the thing that's interesting about group tuple, particularly if you're doing something like sort, and someone asked this yesterday, was what happens when you are running through this pipeline and it's got this, the data flow model, so the data is going into the channels. If it has to do something like a sort, it actually has to wait for all of the elements of that channel. Essentially, the operator has to receive the poison pill to know, because otherwise it can't sort. It has to know actually what's the full array, the full kind of list of the elements in that channel before it can do that. So that can sometimes, you have to be careful with that in terms of the parallelization, because your pipeline will just essentially wait there if you use group, tuple, and sort. And this is why size can be useful, because you can say, okay, well, actually, as soon as you've got two of them, emit them and proceed with the pipeline. It's more of a something that you'll see as you start to scale up a little bit. Now, the other one that we saw here was around join. In this case, we are grouping, but we're grouping from the same channel. This is one channel, our reads channel. What happens if we've got multiple channels and we want to group them again based on a key? Well, this is what we can use join for. And here I've got the same reads channel as above. And you can see I've got mouse and human and cow. And then the second channel now I've got some, in this case, fake BAM files. And I've got, again, mouse and human and cow. Now I want to join these together so that I end up with, again, like 3 elements, one for each sample, but I want to put those files together. And if we see when we run through this on join here, you can see that we end up in that situation where now we have the fast queue and the BAM all in one. Now, point out, I'm just using, these are actually just strings because this is just for illustration purposes, but the same thing would apply if we used actual files in here as well. So that's a kind of a quick summary on what's possible in terms of the operators there. Again, it's something where having an example can help a lot. There's a couple of exercises on how you can do it. There is one kind of more different operator, and that is called branch. And what branch does is it creates essentially a multi-channel object. So instead of creating a single channel as the output, like all of our operators are taking a channel and essentially creating another channel with some sort of manipulation of this taking place, with branch, we create a multi-channel object. So here you can see that we had a simple channel with, in this case, 5 elements inside of it. And then we want to split it based on what the size of that, of basically what that integer is. If the element is less than 10, we're going to place it into a channel called small. And if it's larger than 10, we're going to place it into a channel called large. And the way that we can access that channel then, and the way that we can kind of see this, is that we can say result, which is in this case, not a channel, but it's 2 channels. And then we can reference that with small. So we can say result small, in this case, view, for running that. It's not used a lot, but sometimes you'll be in a situation where you want to do that there. Okay, that's a kind of summary, a very quick summary of what we've been doing with operators so far.